Hi gang, so here we are in the last section in chapter 4, dealing with systems of equations, and we're going to look at another kind of problem. They're called mixture problems, where you're basically taking one thing and adding it to another and getting a total and trying to figure out different questions around that. So I'll just pose a question to begin with and we'll dig right into it. And again, once more, table is a great way to organize and to solve these problems. So here we have beans being added to corn. We know what the value is per pound, and what we want to do is we're going to make a mixture that costs 65 cents a pound. And so there's a lot of numbers, a lot of ideas cracking around there, and what we want to do is try to organize them in a table. And here's how that table might look. So for the beans and for the corn, the things we need to know is how many pounds of each, what do they cost per pound, and what's the total value. And so we can figure this out. The question was how many pounds of beans? That's the big thing, and that's B. And we're going to mix it with 16 pounds of corn. Okay, so that's 16. The cost of beans is 90 cents per pound, and the cost of corn is 50 cents a pound. So in terms of cents, this is worth 90 B cents, and this is worth 800 cents. So there we go, filling in that table. Now we have to figure out where we get an equation from. And one thing to notice here is that this really doesn't require a system of equations. So what we know is that the total pounds is B plus 16. The cost of this, remember it's given up top, is going to be 65 cents. And the total value is 90B plus 800. So that's my total row. So do you see what my equation is going to be? The total value, which is 90B plus 800, is equal to the total number of pounds of the mixture times the value in cents per pound. And there is my equation. And if I follow that equation out and I solve it carefully, I'm going to get B is equal to 48 over 5 pounds. So make sure you answer in a full sentence. But there's our first type of problem. That's a mixture problem. Okay, so take a few minutes and read this. And remember, the trick on reading is to read it enough times so that you could tell it to a friend and get all the pertinent information correct. And now let's think about how a table is going to look. So why don't you take a minute and press pause and write down what you think the table would look like. We'll see if we agree. So did you get something that looks like this? And what we want to figure out is how much chocolate and how much mints. So that's the big question. So we'll call this C and we'll call this M. Now the chocolate we know is $1.80 per kilogram, and the mints are $3 per kilogram. So the value of chocolates is 1.8 C, and the value of the mints is 3M. Got it? Now, what else do we know? In terms of the total, we know that the total kilograms here, I guess I mixed up kilograms and pounds in that top problem, but let's stay with kilograms. This is going to be 15. The cost is going to be $2.20 per kilogram, and the value is 1.8 C plus 3M. So do you see what the equation is going to be? Take a second and see if you can figure it out. So one equation is M plus C equals 15. And the other equation is going to be 1.8c plus 3m is equal to the total value, which is 15 times 220, or 33. And those are my two equations. And once again, it looks like substitution is the best way to solve this. And we've practiced a bit, so I'll let you work on this. But what you should get is that m is equal to 5 and c is equal to 10. And those are measured in kilograms. So let's go up here and change that to kilograms just so that we stay legit. Okay, let's see, do we have another problem? Yep, one more. Alrighty, so this is the last one we'll look at. And what we're doing is we're adding pure bran to 50 ounces of cereal that's 40% bran. And we're going to get a mixture that's 50% bran. And the question is, how much of the pure bran do we have to add? So guess what? A table works. So let's do the same thing. Take a few minutes and see if you set up a table. Press pause and let's compare it with what I get. So here's one way of setting it up that I think works. What we want to know is how much of the pure, which is going to be 100%, is going to be added to 50 ounces here, which is 40%, to make a mixture that has 50% bran flakes. So let's see what we can fill in. The question is, how much of this pure do we need? So that's P. We're adding it to 50 ounces of the mixture. The percent bran is 100% here. The percent bran is 40% here. Maybe I should make this a little bit clearer. Percent bran. And then finally, how much do we have? Well, if it's 100% bran and we have P ounces, then the amount of bran is P. And these are percents. So if we have 50 ounces, that's 40% bran. The total amount of bran is 20 ounces. So let's see now, what is our equation going to be? We want the total, let's take care of that. The total is P plus 50, and the total is going to be 50% bran, and the total amount of bran that we get is P plus 20. So think about this. If we have this much, which is 50% bran, and the amount of bran is this, well, do you see what the equation is? 50% of 50 plus P must equal P plus 20. And once again, I'll let you do all the legwork on this, but you should come down and find out that P comes out to be 10. Don't forget, always answer in a full sentence. Okay, so there you go. And once again, please notice on this problem, it wasn't a system of equations. All we needed was one variable. All right, so that ends Chapter 4. See you back on Chapter 5 when we start talking about polynomials. Ciao, ciao.